This is the last of our videos about polynomial operations. On this one, we'll have to keep in mind our exponent rules for division. If you haven't checked out the exponent rule for division video, you should definitely do that before starting this lesson. So remember that rule is to subtract our exponents. And we're going to be dividing or reducing our coefficients. With polynomial division, most of what we're going to be able to do is actually going to divide. We typically won't have fractions left over in our final answer. For division by a monomial, which is the primary thing that we work with here in Algebra 1, it's a two-step process. And even step 1 is something that you're probably going to eventually skip. And that's to rewrite each term over the denominator. If you aren't up on your math lingo, remember the denominator is the bottom part of your fraction. So like this 2 or this 3x squared. So really all we're doing in this first step is splitting up the big fraction that it gives us. And like I said, as you get comfortable with polynomial division, you'll likely feel comfortable enough to skip that rewriting step. I'll do it for the first few, but then I'll also start to skip it as well. Once you have your big fraction all split up, all you have to do is to reduce each of those smaller fractions. And that's the step where our exponent rule will actually come into play. So if I take a look at my very first polynomial division problem, 8x plus 6y divided by 2. My first step is to rewrite each of these two separate terms over that denominator. So I'm going to end up having 8x divided by 2. I'm going to keep that same sign here in the middle, and then 6y divided by 2. So I'm not quite finished. My next step is to reduce each smaller fraction. Now there isn't a whole lot to do here. I'm going to do 8 divided by 2, which is going to give me 4. That x doesn't have anything to reduce with, so it just drops down. I'm going to keep the same sign. 6 divided by 2 is 3. And again, that y doesn't have anything to go with, so it just comes down as well. Now, you can check for like terms, but typically you won't have any at this point. So that makes 4x plus 3y my final answer. Now, when we start throwing variables in the denominator, which is what you're more likely to see, we're going to end up having to use that exponent rule for division. So if I start by rewriting, I'll have 15x to the 4th divided by 3x squared. I'm going to keep that same subtraction sign there in the middle, and then we'll have 12x to the 3rd over 3x squared. So I'm going to reduce each of those fractions. 15 divided by 3 makes 5, and here's where that exponent rule comes into play. 4 minus 2 still makes 2 as my exponent. On the other side, 12 divided by 3 makes 4, and 3 minus 2 makes 1. And remember, that would just be a plain x. If you feel more comfortable putting the 1, you're more than welcome to. You know, like terms, so that makes that my final answer. Other things that can happen. Okay, I'm going to rewrite this one. Is, if you'll notice, the second little fraction here has the same thing on the top and the bottom. You might already know how that's going to turn out, but you'll see here very shortly if you don't. 36 divided by 6 is going to make 6. 4 minus 2 is 2. Now over here, 6 divided by 6 does make 1, and x squared cancel out. 2 minus 2 would be nothing, or 0, which follows right along with that exponent rules for 0 exponents. And that actually makes this my final answer. So it's a little bit weird that we get 1 here, but it's a-okay. Don't think of this as canceling everything out. Really, you are dividing. 6 divided by 6 makes 1, not 0. So we do still have a placeholder for that. All right, it can get a little bit funky whenever you start dividing by negatives. It doesn't happen super often, but it can. This is also going to be the last one that I'm going to end up rewriting. So I have 3x to the 8th divided by negative 3x. And then I also have minus 18x to the 6th divided by 3x. So 3 and negative 3 will make negative 1, and 8 minus this 1 on the x will make x to the 7th. So really I have negative x to the 7th. Again, if you feel more comfortable writing the 1 in there, just as a placeholder to make sure that you remember to do 3 divided by negative 3, you can totally do that. The other thing that you're going to want to do is here, be careful. You have minus, and then you're going to end up with a negative 6 whenever you divide 18 and negative 3. So that is going to change your sign in the middle to a plus. And then we do still subtract 6 minus 1 here is going to make 5. Again, no like terms. And that makes this my final answer. So just be careful of the sign changes. Now, if you're feeling comfortable, then you can stop rewriting. If you would like to keep rewriting, you can pause before I keep going. If you're looking to kind of shorten these problems without this rewriting step, you can kind of just make a pit stop and think of it like this chunk divided by the bottom, and then same thing with this chunk, and just treat them separately. And that's exactly what I'm going to do. So I'm going to start with this first division. 5 divided by 5 makes 1, and I'm not going to write that part. 6 minus 3 makes 3. 9 minus 7 will make 2. So I finished off this term. 5 divided by 5 was this 1 right here. 6 minus 3 was 3. 9 minus 7 was 2. I'm going to bring down that same sign. Okay, I'm not dividing by a negative, so I don't have to worry about sign changes. And then I'm going to start dividing the same thing on this next term. So it's not a good idea to slash those 5s because you're going to need that 5 over here as well. 20 divided by 5 is 4. 4 minus 3 is 1. And 7 minus 7 would cancel each other out, so there's no longer a y on this term. And that makes this my final answer. So it can go really fast without a whole lot of work being shown, which I know some of you will really appreciate. Even if it looks really crazy with 3 variables and all these exponents flying around, it does still work the same way. So although it looks a little intimidating, don't let it freak you out. So we have 18 divided by 6, which is 3. We're just going step by step. So I'm going to compare my x's. 10 minus 8 is 2. 6 minus 5 is 1. And 4 minus 4 would cancel those z's out. I'm going to bring down the sign. I'm going to keep on going. So now we're on this middle term. 48 divided by 6 is 8. 20 minus 8 is 12. 10 minus 5 is 5. And 8 minus 4 is 4. So that one kept all the pieces. All right, we still have one more term to take care of. I'm going to bring down that plus sign, and I'm going to keep on going. 6 divided by 6 makes 1. 8 minus 8 makes 0. 5 minus 5 makes 0. And 4 minus 4 makes 0. So my final term in my little expression is just 1. Definitely no like terms. All those look pretty different with all the exponents and whatnot. And that makes our final answer for that chunk. Now's a great time to go ahead and pause your video and try these two. They're a little less intimidating than that last one. So if you've tried those, your final answers here should be 3x to the 5th minus 5x squared on the first one. Okay, again, that's coming from 15 divided by 5 making 3. 8 minus 3 makes 5. 25 divided by 5 is 5, and 5 minus 3 makes 2. The second one is going to be 3x squared y to the 6th plus 1. 27 divided by 9 makes 3. 5 minus 3 makes 2. 7 minus 1 makes 6. We bring down our sign and then work on the second term. 9 divided by 9 makes 1. And 3 minus 3 and 1 minus 1 both make 0. Now the other part of this section requires factoring, which we haven't talked about yet. It actually comes up in our last unit, and that's division by a binomial. So 2 things. It typically has a 2-step process, the first step being to factor. And that factoring happens typically up on the top. Your factoring is going to cause things to look like polynomial multiplication. So we're going to skip the step where you actually factor, and I have these already factored for you. So it's where it's already split up and looking like it's ready to go. Once you have a factored numerator, then all you have to do is reduce. Factoring is actually the hardest part of these problems, but because we haven't looked at factoring yet, we're going to take that part out of here and just kind of introduce you to division by a binomial. So what happens is you have to treat binomials like an entire unit. So you can't think of this as an x and an 8. You have, because of those parentheses and because of this division bar, you have to think of this as x minus 8 and x minus 4 as one cohesive thing. So I'm not allowed to just say, oh yeah, x and x cancel out. 8 divided by 4 is 2. Can't do that. What we have to treat this as is like this has to be in parentheses as well. So what you're looking for is a match on the top and the bottom. So I'm looking for another x minus 4, which I have right here. So those 2 entire chunks are allowed to cancel each other out because they would be exactly the same thing, no matter what your x is. So whatever chunk is left, in this case x minus 8, becomes your final answer. So if I look at the next example, again, I'm just looking for a match with 3x plus 2. So if I look across the top, here's my 3x plus 2. 3x plus 2 and 3x plus 2 will cancel each other out. And that'll leave me with the other piece there, 3x minus 2, as my final answer. All right, sometimes we have plain numbers out in the front with a lot going on. In this case, hopefully you recognize that I'm going to end up canceling out the 2x minus 5. And anything that's left up there on the top becomes part of my final answer. So I have the 2 and the 3x plus 4. Now, depending on what your instructions say, if they want you to simplify this further, you could distribute this through. This would be an okay answer. Distributing it through is what I think I'm going to stop with. So 2 times 3x makes 6x, and 2 times 4 makes 8, using that polynomial multiplication. We'll revisit this again whenever we do our lessons on factoring in the last unit.